How's it going, guys? In today's video, it's basically a lecture. I'm not gonna have any examples. I'm just gonna describe or explain in detail about the definition of continuity, okay? And I'm gonna give 3 different definitions that state the same thing in different ways, okay? So the first one is the one that you're gonna see mostly, which is the one that involves limits. So it says, let f be a function defined at least on an open interval c minus delta, c plus delta. We say that f is continuous at c if the limit when x approaches c of f of x is equal to f of c. Okay? Notice that in this definition, you're not going to see that a lot in other books, or you might, depends on the book. It starts with at least on an open interval. Why is that? Why do we restrict ourselves by at least an open interval? Well, notice that we're talking about the domain of the function. So we can restrict ourselves to a point of focus and see if this function is continuous in there. Now you can say, well, the functions, can they be continuous everywhere? Well, of course, you know, the open interval could be minus infinity and infinity, right? I can have minus infinity comma infinity, and those are open intervals, and that's equal to the real set, right? The set of real numbers. So it's just stating, like, it doesn't have to be continuous everywhere unless c is inside that interval. Because if we're looking for the interval of a point, notice that this is continuity on a point. It's not continuity on a set. And that's very big if you go to like advanced math, like topology. They talk about the difference between continuity as a set and continuity as a point, okay? But in here, in calculus 1, we concentrate on continuity on a point. So if we want to know if a function is continuous on the point C, then C has to be in some sort of interval, okay? Because we can't just define a function for one point. We can, but then, yeah, it's obvious that is continuous on that point because it's the only point. So usually you want to have like more values next to it, okay? But you can chop the function and say, okay, from this point to this point, C is continuous in this interval, okay? So that's the definition of the limit. Now I'm gonna make the definition using epsilon delta. Well, I'm not going to make it. I'm just going to show it. So it says f is continuous at c if for each epsilon greater than 0 there exists a delta greater than 0 such that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus f of c is less than epsilon. If you went to the previous, to the first video of epsilon and delta, you'll see that there's only 2 differences with this definition in the definition of limit. First is that there's no restriction here for x minus c being greater than 0. And if you went to the video, you'll notice why. Because now x can be equal to c. So that restriction is gone. The second difference is that instead of L, I have f of c. So f of c is my L, right? Just like here. So instead of any L, L is equal to f of c. Okay? So the limit, the value of the limit is equal to the function evaluated as c. That's the main difference between being continuous as c and the limiting exist. In the previous videos, I constantly said, like, at the value of c, it doesn't have to be equal to the limit. But if it is, then the function is continuous at c. That's how it wraps up into continuity. You must have a limit exist, and you must have the point C exist, and they have to be equal to be continuous at C. And continuity is huge, because everything after this day in math is based on continuous functions. Why? Because continuous functions are the most common ones, right? Sine, cosine, exponential, logarithms. Most of the families of functions that we know, that we are used to using in everyday math, are continuous functions. Now, there's a infinite amount of families bigger than the continuous functions, which are the discontinuous functions. But those functions are not very useful, or at least we haven't found much use for them. Okay? So continuity is huge. Now, the third definition, which is almost analogous to the definition of limit, is f is continuous at c if and only if f of c is equal to the limit when x approaches c from the right of f of x, which is equal to the limit when x approaches c from the left of c, right? So those three definitions represent the same thing, is the continuity at a point. The way you're going to use them depends on the problem. So if the problem is asking, find the definition of, or find if this function is continuous using epsilon and delta, then you're going to use the epsilon and delta. If you have a piecewise function, which is the classic in calculus, you're going to use this one that I just mentioned. Okay, and if you have a graphical representation, you either use the first one or the third one. So depending on the problem, you use the definitions you need. Okay, again, this video was just more like educational than actually solving anything. In the next video, I'm gonna give examples and how to solve them using continuity. Okay, so I hope you liked it. Like the damn video. Like the video. Subscribe to motivao. Go to my website, www.motivao.com, and I don't know what to say. Have fun. Enjoy life.